For today's lesson, we're going to look at something called a biconditional statement. A biconditional statement is kind of like a conditional statement, but instead of using the if and then, the if at the beginning and the then in the middle, the biconditional statement uses this special phrase, if and only if, in the middle. So, whereas a conditional statement looks like if blank, then blank, what the biconditional does is it eliminates the if at the beginning, puts an if and only if in the middle, and then the conclusion at the end. So the if and the then disappear and get replaced with the phrase if and only if in the middle of the statement. That's what's going on with the biconditional statement. What a biconditional statement does is it takes the place of the conditional statement and its converse. It's basically saying that both things are taking place at once. So symbolically, you'll notice it has P with a double arrow Q. What that's really meaning is it's P arrow Q and Q arrow P. P implies Q and Q implies P. That's what a biconditional statement does. It takes the place of a statement and the converse and combines them into one single statement. That's what they do. Now, what is important about biconditionals? A lot of times when we're writing good definitions of things in geometry, what we want to be able to do is to write them as biconditionals. For example, I could say if an angle measures 90 degrees, then it's a right angle. But I could also work it backwards and say if an angle is a right angle, then it measures 90 degrees. Since both of those are true, I can write those as a biconditional statement, a good definition. An angle is a right angle if and only if it equals 90 degrees. It's a nice thing to do when we're working with definitions. And we're going to practice that a little bit. Here's a similar statement. If two lines intersect to form a right angle, then they are perpendicular lines. That's a regular definition. I want to rewrite this as a biconditional. So what am I going to do to rewrite something as a biconditional? First thing we're going to do is we're going to drop the if. And we're just going to start with a capital T here. So two lines intersect to form a right angle. We're going to get rid of the then. We're going to replace that with the phrase if and only if they are perpendicular lines. Now, I'm cheating a little bit. I have luxury. I have a smart board. I can do this sort of thing. When you're copying things out of the book, you're actually going to have to rewrite the whole sentence. Sorry, guys. That's a little bit more work for you. But for the sake of a quick demonstration, I did it this way. So again, we drop the if, we drop the then, and we replace that with the if and only if in the middle. Now, could I switch that? Could I say two lines are perpendicular lines if and only if they intersect to form a right angle? Sure. I could switch that, but why mess with what's already there? Keep the order the same as you found it. An angle is a right angle, then its measure is 90. Again, I'll write this whole one up. An angle is a right angle if and only if its measure is 90 degrees. There we go. Rewrite the definition of congruent segments of a single biconditional. The definition said if two line segments have the same length, then they are congruent segments. Again, we would cross out the if. Two line segments have the same length, get rid of the then. Replace that with what magic phrase? Yes, if and only if they are congruent segments. That's how we write a biconditional statement. And again, like I said, this biconditional statement is really taking the place of the original conditional and its converse. So we could do this backwards too. All right? And to test whether or not a biconditional is true, both the statement and the converse associated with it have to be true. So, I could say something like this. You are a red hawk if and only if you attend Milton High School. That's a biconditional statement. Let's rewrite that. Let's break it the other way into just a statement and its converse and evaluate whether or not this biconditional is true. So let's start by rewriting this as a conditional. If you are a red hawk, so the conditional, then you attend Milton High School. Well, is that true or false? If you are a red hawk, then you attend Milton High School. Well, that statement's false, isn't it? Because there are other schools that have the Red Hawks. There's a college in Ohio that uses Red Hawks too. So that would be a false statement. Which means if this is false, that means this biconditional is also false. But let's finish the job. Let's state what the converse would be. The converse would be if you attend, and I'm going to abbreviate here, Milton High School, then you are a red hawk well, that statement's true. Well, I'll assume that we're talking about schools in Wisconsin here for Milton High School. I'll assume that we're talking about our Milton High School, not some other Milton High School somewhere. So given that assumption, yes, that is a true statement. So even though the converse is true, the statement itself originally was false, making the biconditional false. You'll be writing back and forth with biconditionals, evaluating truth, things like that. This is what we do with this sort of thing. So that's our lesson for today. Again, more time in class spent talking about it. We'll see you in class.